In this video, I want to briefly introduce a couple topics. The first is simple graph specification in igraph, and the second is some layout tools for small graphs using the tkplot tools also in igraph. I'm going to focus on a theoretically interesting class of small graphs, namely triangles. There's lots of discussion of triangles in social theory. Zimmel, a key early influence on the development of social network analysis, for instance, emphasized the importance of triadic relationships. It goes back in anthropology as well. In 1929, Evans Pritchard used triadic reasoning to explain what seemed like a real paradox in his onde filial relations. So triangles are really important. They appear over and over again in our theories and in our analyses. So it's probably a good idea to know how to specify them and how to plot them, because we like to plot our graphs. All right, so I'm going to talk about two different ways of specifying our triangles. The first is using the igraph function makeGraph. And as with a lot of these things, you can actually simplify that a bit. You'll see in the R script file up here, I have rather than make_graph, it's just graph. We need to make sure we have igraph, library igraph, of course. Yes, good. And now we can enter this. We'll see that it takes 3 arguments. The first argument is a vector, and that vector is a vector of couples. It's couples of vertices, and those are the edges of the graph. So there's an edge from 1 to 2, from 2 to 3, and from 1 to 3. We then have to specify the number of vertices total in the graph. That's 3. And then we have to specify whether we have a directed or an undirected graph. And for makeGraph, the default is that it's directed. We have to tell it we don't want a directed graph here. So we say directed equals false. And following the typical R conventions, as long as you specify enough of the argument so that it distinguishes it unambiguously, you can just shorten it. So rather than directed equals false, I just have dir equals false. Okay, so now having specified our triangle, we can look at it. We see that there are 3 vertices and 3 edges, and that they're edges from 1 to 2 and 2 to 3 and 1 to 3. That's good, because that's what we specified. Next, we can plot it, plot G. And we can see that the plot appears in our plotting window, and it's kind of an ugly color. That's the default vertex color for igraph these days. I'm not a huge fan of it. And so I typically specify my own vertex color. I like sky blue too. Turns out it used to be the default for igraph before it changed to this orange. We can see another thing that's a quirk about the way igraph plots things. It will be slightly different each time we plot it. And the layout algorithms are non-deterministic. And that can be a little frustrating, because maybe you want a very specific look to your graph. Typically, when we plot a triangle, we're going to want the base to be parallel to the short edge of our paper or our screen. And so the next thing we're going to do is we're going to use some interactive layout tools that igraph contains. Oops, I put my screen to sleep momentarily. So let's move on to doing that. This interactive tool uses the tkplot libraries, and we use it by calling tkplot G. What that's going to do is it's going to launch an X window external to R, and you need to have the software installed. If you're using a Mac, the main client is Xquartz. It's pretty straightforward to download it and install it. What we get here is our X window where we can grab onto the vertices and we can drag them. Okay, We can drag that one there, that one there. It's a little bit of an imprecise art. It would be nice if there were some guidelines here, like a grid or something. So we're going to do this mostly by eye. You can also see that there are a few examples of layouts that it will give you that you can play with. I'm not going to do that right now just because we seem to have dragged ourselves into a pretty good looking layout. This is more or less what we want. I'm also going to draw your attention to the top of this window. It says graph plot 1. We'll need that as we go back to R. So now we've laid it out by hand and we want to get it back into R. The command for this is tkplot dot get chords for get coordinates, and we're going to pass it as an argument the tkplot ID, which is the window number, right, which was 1. Okay, so there's our output from that. It's a 2-column matrix. The first column are the x coordinates. The second column are the y coordinates. Okay, and I called the command there so that we'd see it echoed on the screen, but we want to give it a name. Let's call it try chords get tkplot get chords 1. Okay, and now let's plot using that layout, but we'll also compare it to the sort of random layouts that we get. So the way we can do this in a nice efficient way is to plot them side by side next to each other. So par mf row equals c1, 2. So I'm setting up the plotting space so that it's 1 row and 2 columns. So side by side plots. And we can now go back to our plot with the more or less random layout. And now we can use plot G vertex color equals sky blue 2 using our layout. Layout equals trichords. And there we can see the comparison between the random layout and the layout that we've specified using the interactive tools. So that's cool. Often you will want to save your layout that you've worked so hard to get using the tkplot. And you can see up here in this little window that holds an R script of stuff that I've done before. I've actually done that. And these are, you'll notice that the numbers are pretty similar to what we just interactively got. And that will also produce a nice triangle with a nice layout. So if you want to, say, use an R Markdown document where you're going to want to call the layout, you want to make sure that you save that layout, as I did here. Okay. All right, let's think about another way of specifying a simple graph. We'll use a different technique. We'll enter the graph using an adjacency matrix and then convert the matrix into a graph object. I should say before we do this that in general, I don't recommend using adjacency matrices as a way of specifying graphs, but it's a fine way to do it when the graphs are small. This time, we'll also work with directed graphs because it makes it a little more interesting. We'll specify the matrix the way we would any matrix in R, passing it a vector of values and specifying the number of rows and columns. So because I don't want to have to type that in, we'll go here, all right? And so we've got the command A gets matrix. We pass it a vector of the matrix elements, okay? The 0, 1, 1, 0, 0, 1, and 0, 0, 0. Those are going to be the rows of our matrix. We then have to tell R how many rows are in our matrix and how many columns are in our matrix, 3 and 3. And then this is pretty important. This can be a little bit of a gotcha for people who are new at R. R uses column major order by default when creating matrices. But when we enter matrices by hand, as we are here, we typically do it in a row-wise way. This is the 0, 1, 1 is our first row, the 0, 0, 1 is our second row, the 0, 0, 0 is our third row. And so we have to specify for R to do it by row. Okay, so by row equals true. Okay, so let's enter that, take a look at it. Oops. Change our focus, take a look at it. There's our matrix. Okay, we can now read that into R using the function graph from adjacency matrix. Okay? It takes the argument of the matrix that we just entered, and we have to tell it whether we want it to be directed or undirected. Unlike the case of make graph that has a default for directed graphs, here you have to actually specify whether you want it directed or undirected. So we say mode equals directed, and then the last argument, diag equals false, means that we don't have self loops, that the function should ignore the diagonals of the matrix. We happen to not have anything on the diagonals, but it's good to be thorough about this. So we'll do that, enter it, look at G. We've got 3 vertices, we've got 3 edges, and our edges are from 1 to 2, 1 to 3, and then 2 to 3. Okay? So we'll take advantage of our layout that we used from before, trichords, and we'll plot our new G. All right? And what we see is that we have arrows going from 1 to both 2 and 3. All right? And on the bottom from 2 to 3. Okay? So let's enter a second matrix and convert it to a graph and plot it, and then we'll talk about what the difference between these matrices are. So here I have a second matrix. A1, it gets this vector of values, first row, second row, third row, number of rows equals 3, number of columns equals 3, by row equals true, really important, don't forget that. We'll convert that to a new graph called G1. We use graph from adjacency matrix on A1, the mode is directed, we ignore the diagonal, and now we can plot that. All right, so we've got our nicely laid out triangles right next to each other. On the left-hand side, we have a transitive triangle. So suppose the relation we're defining, our edges in response to, is dominance. The transitive triangle has the sensible property that if, for a dominance relation, that if 1 is dominant to 2, right, so there's a directed edge from 1 to 2, and 2 is dominant to 3, then it makes sense that 1 is also dominant to 3, because 1 is dominant to 2, presumably it should be dominant to 3 as well. Transitivity of this kind leads to hierarchy in social structures. Okay, our right-hand triangle, on the other hand, is cyclical. 1 goes to 2, 2 goes to 3, 3 goes back to 1. We probably wouldn't find a cyclical triangle in a dominance relation, but suppose we have something like a marriage exchange across 3 sections of a system of a kinship system, or generalized reciprocity. 1 provides a marriage partner for 2, 2 provides a marriage partner for 3, and 3 provides a marriage partner for 1, completing the cycle. Cyclicity leads to egalitarianism. We'll talk a lot more about triangles and triadic relationships in class, but I hope that this brief video proves helpful in getting you started with social network analysis in R and igraph.